Alright, hello everyone, welcome back. So next, let's talk about new model. It's called GAN, or Generative Adversarial Net. So GAN model is one of the most famous model used nowadays. It has been well studied in both academia as well as used in the industry. If you check online, you can see lots of news articles, reports, as well as papers. They are all being using the GAN as a model, and it can be used to generate images in different styles. And besides apply to images or computer vision area, the GAN model has also been extended and used in many other domains like natural language processing, graph mining, and etc. The generative adversarial net actually has created a new way to start deep learning. It can be applied to generate some new images, and it can be also be applied to train the models in a different way. So in this talk, we'll discuss what is a GAN and how to train a GAN as well, how to apply a GAN to generate some new images. And here's the outline for today's talk. In the very beginning, we will discuss about two different kinds or different categories of models. The first category of models, they are called discriminative models. And the second category of the models, they are called generative models. They are very different models, and we will discuss about their differences in today's talk. Then we'll talk about the autoencoder as a generative model and what is the shortcoming to use autoencoder to generate some new data. After that, we have several cut-in pages to talk about what is a GAN. The GAN scenario, right? And we discuss what is a GAN between agents or among agents and how to use GANs to design new deep learning models. Then I will discuss about the GAN model architecture and how to incorporate generative models and discriminative models into one model framework, and they can form a GAN among these two models. And then we discuss how is the iterative fitting process in the GAN model. Then finally we'll discuss what can the model do, the GAN model do, and what can they generate. Okay, so let's talk about what's the difference between discriminative models versus generative models. So far, we have talked about different models in deep learning already, and majority of them, they are about discriminative models. Then what is a discriminative model? So formally, given some seen or observed data sets, we can represent data set as D, right, as shown here. It covers both the features as well as the labels of the instances. So normally for classification task, for example, we want to learn a mapping, right, to project the features to their labels. So we can denote this F, this model as one mapping F model, right, as shown here. So this model can be learned by fitting the training data set we provide with the model, right? So we can denote this mapping as F model. So besides this F model, this mapping, we learn from the training set. There also exists another mapping, which is the ground truth mapping or the true mapping, right? We can denote it as F data. So the F data is the underlying mapping that governs all the data instances to project the features to their desired label, right? However, the F data is unknown. We don't know that, right? Otherwise, we don't need to learn the F model anymore. So because we don't know the F data, we want to learn a model, which can be learned by fitting the data set we provide as the training instances. So normally we have an assumption, right? So by fitting the data, we can learn F model. We assume this F model, this mapping will be very similar to the model. This F data model, which governs the true data distributions in the real world. So this F data will cover both the seen training data set as shown here, as well as some unseen data instances, like in the testing set or in some other future data instances. So you can see for discriminative models, we want to learn this mapping by fitting the model to the data set, and we assume that this model will be very similar to the true mappings underlying these kinds of models. So far, we have introduced different kinds of discriminative models already, right? And like MLP and CEM models. So we can apply these two models to the classification of the images we provide. Like we can provide one image, we can learn one MLP model to classify it, right? This is also what you do in your project stage 2 already. Then similar for the CEM, we can also build one CEM model to classify the images, right? With the CEM model covering both the convolution layers as well as pooling layers, together with some full connection layers. So by applying both MLP as well as CEM model, we can classify them, right? Classify the image instance input. And they are both the discriminative models. Okay, then what is the generative model and what's the difference versus discriminative models? So we can provide with some high-level ideas about generative model in this page. Before we mention that to train a discriminative model, we need to have a training set. Then the question would be, how can we obtain this training set? we have to compose the training set via some way or some method, right? So the way we can compose the training set is via the random join, actually. So let's assume we have a global pool of data instances. And how can we obtain the training set? The training set can be viewed as a subset of the global data instances or global data set, right? And we can compose the training set via the random join. So given the data instances of the global pool of all the instances covering all the seen and unseen data instances, we can randomly join some data instances samples to compose the training set, the seen or observed data instances. Right, and the join process will be following some distributions, not following the true data distribution. Right, this is the way we can compose the training set. Besides these true data instances, we may also want to build a model which can generate or can draw some data instance samples following some other distributions. Right, here we will assume we can also build a model to draw or to generate some data instances as well. However, we assume the join process will follow a distribution defined by the model. Right, so you can see the difference. Before, for the discriminative model, we want to build a model which can fit the data set, which will be very similar to the true mapping governing the distributions. And here we want to build a model which can generate some data instances. And the target is also very different. The target here, we want to ensure the model can approximate the underlying data distributions. In other words, we want to ensure the distribution, we define by the model we create, which will be very similar to the true distribution of the data instances governing the data set we have. Right? So you can see the difference. Before, for the discriminative model, we want to ensure the model we learn by fitting the data set will be very similar to the true mapping governing data set. Here, we are focused on building a model to generate some data instances, right? Which will be, the generation process will be very similar to the join process we compile the training set before, right? We want to ensure that the distribution of the data instances will be very similar instead. They are very different, you can see, right? And you may also wonder why we need to care about the generative models and why we need to study them. Because in the real-world application, some of the problems may require us to build a generative model for us. We can show you with some examples. Like when we are studying the speech synthesis from text to the generated speech, we have to build a model which can generate the speech, right? Also, it will be very similar to do the machine translation among languages from English to French or from Chinese to Japanese. We may also need to have a model which can do the generation for us, right? And for some other cases or other tasks, we also need to involve this generation process inside the model design or model architecture, like the image segmentation. Given the input image, how can we segment them, these regions? In other words, we have to generate these regions from the image, right? We also need to incorporate the generation process inside the model architecture. Besides the generation as one component in many models or in many tasks, we may also need to study the generative model as the environment simulators. If you have ever heard about the self-driving cars, when we train the self-driving this model, right, we have to collect or accumulate not so trained data from the real world. So compared with the real-world data connection or this accumulation, another way we can do is to do the generation or do the simulation of the real-world environment. We can do the simulation instead to generate some simulation cases instead, right? Which will be very helpful for some of the learning tasks like the reinforcement learning and some planning tasks. Besides these kinds of applications, we can also consider to use generative model to help us to the leverage of the unlabeled data instances, because we can generate some new data instances which can be unlabeled, and we can incorporate them to train the models as well. So these are the potential applications of the generative models and why we have to care about them.